Hey, how's it going? Fred here, AF Math and Engineering. We are continuing with Calc 2 in university, still in first year, but we're getting into some trickier stuff. We are doing our second video on integration by parts, and we're going to do something a little bit trickier than we did last time. Okay, so what I've done is I've written in the top right here the acronym LIATE. Okay, and LIATE stands for logarithmic, inverse trig, algebraic, trig, and exponential. And this is the order in which you should select your u variable in the problem. Okay, so what I mean by that is we have our integration by parts formula. So we have u dv is equal to uv, okay, minus integration of v du. And as we remember from the last video, or remember from what you're learning, okay, you select your u and your dv, okay? And how you select your u is dependent on whether or not you can solve the problem. If you select the wrong u, the question can continue on forever. And the idea is that you want to select the u that makes the problem more simple, all right? But just choose u to be in the product of the two functions, okay? Select your u to be the first one that appears in this list. So if there's a ln function or a log, that's your u. Then if there's an inverse trig, that's your u. If there's an algebraic, that's your u. Okay, so let's take a look at this question here, all right? And we have an algebraic function and an exponential function, okay? So since the algebraic function appears first on the list of LIATE, we're going to select that as our u. Okay, so our u is going to be z cubed, okay? So that just leaves the other function here, which is e to the z, okay? That is going to be our dv, right, by default. So how do we continue? Well, we just need to calculate our du. So we're finding all the components of the formula that we need, okay? And du is 3z squared, okay, dz. And the integration of this, e to the z, is just e to the z. Okay, so it's supposed to be a v. Very good, so we've started the question, all right? We've found our u, our du, our dv, and our v. And now we need to just go ahead and plug them into the formula. All right, and this question is going to have a little bit of a trick to it that I'm going to get to, that you're going to have to look out for on test, because this is almost 100% coming on the test. And we'll get to that in a second. So let's start. We have the integration of z cubed e to the z dz, okay, and that's equal to uv. So we're just plugging in here. We have z cubed e to the z minus the integration of v du. All right, so e to the z du is 3z squared dz. So what you'll see that that has happened here, okay, is that we're left with another product of two functions in the integral. Okay, so how do we solve that? What that means is that we're going to have to apply the integration by parts formula again, and only apply it to this section, okay? Because this is done, this is evaluated, that's finished, but inside here needs to be done again. So what we're gonna do is we're gonna take this constant here, we're gonna move it outside of the integral, okay? And we'll rewrite that as z cubed e to the z minus 3 integration of e to the z squared, okay? Now, with this done, all right, we're going to do this portion by parts again. So I'm just going to bring this down here. So let's select our u again, okay? And our u is going to be the algebraic. It's exactly the same thing as the start, just one power less. And as you can see, the power of z is decreasing, and that's what we want, right? Because then we're going to have z, and then we're going to differentiate, and it's just going to be dz, and all we're going to be left with is e to the z. So as you can see, the problem is getting simpler and easier to solve. So we have our u is equal to, okay, z squared, okay, du is equal to 2z dz, okay, our dv is equal to the e to the z, all right, and v is simply equal to e to the z. Okay, now, and I'll just kind of draw a line here to separate the first part of the question. And now, let's go ahead and let's evaluate this integral again. Okay, so we have z cubed e to the z minus, and remember we have that constant outside now. Now, let's write our brackets. The brackets are very important in this question. Okay, Okay, we're going to use the formula again. So let's plug in u and v here. So we have e to the z, z squared, right? Minus the integration of v du. So our v is e to the z again, and our du is 2z dz. Now, what do we have? Well, as you can see, once again, we have a product of two functions inside the integral, all right, that we have to evaluate. What does that mean? We need to do it one more time, okay? And as you can see again, like I mentioned before, the power of z is steadily decreasing, okay? So once this z disappears, we're going to be left with a very easy to deal with integral. Write another line, okay? This is, I guess, step 1, this is step 2, this is going to be step 3. And let's take this, okay, let's move that constant outside of the integral, and let's take this term here, and let's go ahead and define our u and our dv. Okay, so we have our algebraic function here, that's first on the list, so that's going to be our u, and the constant's moved out, so that's just z, okay? du is equal to dz here, okay? dv is, again, e to the z, dz, and v is equal to e to the z, right? Because the integration of e to the z is just e to the z. So let's go ahead and apply the formula one more time, and that should be it. So we have z cubed, e to the z, okay, we're just copying what we have up here, minus 3 brackets e to the z, z squared, minus, okay, and then we have the constant outside, bracket again, all right, and let's apply the formula using this. So we have uv, okay, we have z e to the z, okay, minus the integration of v du, okay, we have e to the z. Now you'll see du is simply dz now, right? Okay, so we don't have another term multiplied by e to the z. So we have a variable in which we can evaluate within the integral, okay? And if we go ahead and evaluate this, we will be left with, and I'm just going to write this out, very good. Okay, and that is it. Now, let's not forget our plus c, right? Because we lose marks for that. It would be a shame to do the whole question right and simply forget to write plus c on the end. Okay, so I'm just going to write it up here. The integration of z cubed e to the z dz, okay, is equal to this here. Now, I mean, you could simplify maybe that a little bit further. You could factor this, expand, but for this video, we're going to leave it like that. Feel free to try on your own to simplify this a little bit, but this is a very tricky integration by parts question. This is something you can definitely expect on your exam. All right, make sure that you're getting all the signs correct and you're including your brackets, your square brackets, and taking out the constants, because taking out the constants is definitely going to make your life easier. Okay, thanks for watching. Appreciate it. Like and subscribe if you really enjoyed this video and it helped you. And again, thanks for watching.